Good afternoon. I would like to welcome you all to the Department of Electrical and Computer Engineering Senior Capstone Project presentation. I'm Dr. Esther Ososanya, Professor and Chair of the Department of Electrical Engineering. Our senior capstone projects represent the culmination of the educational experience integrating the classroom with real-world problems. The students handle open-ended engineering and computational problems whose solutions require a synthesis of engineering knowledge, computational analysis, creativity, market needs, safety, and aesthetics. Projects are supervised by instructors and industry mentors. Our presentation scheduled this afternoon, starting 2 o'clock to 3:45 p.m. We have three presenters. The first presenter is Keenan Leatham, graduating senior. Project title, Microcontroller Station Utilizing Software-Defined Radio, SDR, followed by Group 2 of Senior Project Capstone Design, Smart Electric Motorcycle Conversion by Victor Ramos, Carrie Beckett, and Ivan Torres. And our last presenter today will be Wireless Power Transfer from No, Omodabi, and Kaluhelu. Next Wednesday, 2 p.m., we're going to have the second round of EE Senior Capstone presentation at 2 p.m. At the end of the presentation, I encourage participants to go to the CIS website and open up the student evaluation form and complete the student evaluation forms for us. In the student evaluation forms, we're looking for student outcomes. The student outcomes describe what students are expected to know and be able to do by the time of graduation. This relates to the knowledge, skills, and behaviors that students acquire as they progress through the program. So please help us to complete the student evaluation form for each presenter or for the group of presenters. A form per project. You put the title, project title, and the team members, and complete evaluation for us. At the end of the evaluation, please submit the form by email to Dr. Ososanya, that's myself. And so the format of presentation this afternoon, the presenter will present PowerPoint slides for 10 to 15 minutes, followed by demo of the hardware demo of the project. And we will open up for questions and answers. Each presenter will have 30 minutes to present, and we have 3 groups. Okay, so over to you, Keenan Leatham, for your presentation. Keenan?
I'm on my screen. Hold on.
Introduce yourself. Wave to your audience so they know who you are. Wave to the audience so they see you.
Hold on.
How do you wave?
Keenan, yeah. So we can see Keenan.
Dr. Ososanya, are you talking to Dr. Dixon?
No, to Keenan Leatham, the presenter.
Oh, okay.
Yeah.
Hold on.
We can see your slide here.
All right. My name is Keenan Leatham. I'm an electrical engineering senior at the University of the District of Columbia. And my senior project is microcontroller radar stations utilizing software-defined radio. So the purpose of my senior project is to create radar stations that can be used anywhere, anytime, any place to access flight data do simulations in real time, and also for hacking and different applications. So what is software-defined radio? Software-defined radio is a radio communication system driven by embedded system. ADSB, automatic dependent surveillance broadcast, allows an aircraft to be tracked. MLAT, the multilateration system, tracks the time of arrivals of each airplane. So this is a MLAT system that you would see at the airport, showing the arrivals and the departures of the airplane. So each airport has an MLAT system showing all this information in live time. On the right side here, is the airport diagram for BWI. Each airport, they outline this. So when air traffic control sees this live data, then they can relay it to the pilots where each plane has to go. They've gotten better with this in the years, because years before, you would have lots of airplanes being taxied, and it would take like a long time to get a lot of the airplanes in the air. So this is one of the real life uses of radar systems and what my system is used for. So the block diagram for each radar station. So the antenna is connected with an RF cable. On the antenna, it's the N male. On the dongle, it's the SMA male. In the hardware demo, I will show all the hardware like in real time, so it'll make more sense. Once that information is gone through the RF cable, then it's processed through the dongle. And once that data is processed through all the ABSD data is processed through the dongle, then it's sent to the Raspberry Pi to the cloud. Once that's done, you can send it anywhere you want, in Timbuktu, wherever you want to send it, you can send that data. And anyone can have access to it, but you can restrict access if it's official or another person. So the possibilities are wide. So the different radar stations. So I have one radar station here in Silver Spring. The other two are at UDC. During the coronavirus, I was able to work remotely. I can access my data, I can access my code, I can access anything I want to at a time notice. So even though I couldn't go to school physically, I can access all this data in real time easily. So I didn't have to worry about being sidetracked with not being at school. The only bad thing was that I didn't have access to a supercomputer, but I could still do remote work here. So the remote connection. So this is how I'm able to access each Raspberry Pi. So if you see here, this is my desktop computer. This is all three of my stations. So the process is, the first thing I would do is I would hit one of these connections. Each of these connections are password protected. Once I put in the password, I have access to any device, any command window, any directories, and I can do this like anywhere. If I'm on, as long as I have an internet connection, I can access the data. So this is one of the biggest advantages of having this, is that one is utilizing a Raspberry Pi, which is a small device, a small microcomputer, which you can carry in your hand, you can carry in your backpack. As long as you have the power on, then you can access the system. Two, you can use any antenna that you please. It doesn't have to necessarily be a huge antenna. It could be a small portable antenna. So the FlightAware interface. So one neat thing I did with radar system is that my radar system is that I saw the flight. So my mother was traveling from Moco, that is in Orlando, to DCA, and I was able to see the flight coming into DCA right when it was coming in. So I knew exactly when to leave. And as soon as I was there, they were there. So I was able to get real meaningful data at the time when I was using the system, proving that it works. Also, I saw other planes that I saw coming into ECA at the time. So this is what the panel looks like. We've been up for about a year. We haven't had any crashes as of yet. No issues, no setbacks really. Things I've been doing by myself and with the help of Dr. O is that I've been updating these systems as there's new updates. So before we were only getting aircrafts, now we can get like helicopters and other things that are flying in space there. Also, recently I saw like a few drones. So it doesn't just see aircraft, we can see helicopters, we can see military planes. For military planes, they're usually X'd out. So you can't see, like unless you have clearance, you can call FAA and they can get you that data if you want to see it, or analyze it further. So this is one of my, I recorded it, like one of my live feeds of like the radar system. So you can access this through command line and also access it through a live server. So if you highlight, and I'll show that later, if you highlight any plane, it will show the route, it will show the stops, the calls, you name it, we have it. Um, one neat thing is it will show the squawk codes. Squawk code is usually a 4-digit code that will that's sent to air traffic control. So just in case if an airplane is hijacked or there's any weird activity, based off the codes that were given by the air traffic control, they can convey different distress calls just in case for emergencies. So this is the big queue. So this is where I do a lot of my error checking and seeing if there's any anomalies or anything off. We've had some instances where some things weren't showing up, so I had to go in the back end and fix some things in terms of measurements, longitude and latitude, things like that. Um, for air traffic control, this is very important because like if we're giving wrong information to our pilots or our engineers, then that could be detrimental because A, like if a plane hits another plane in the air, that's bad. B, if we're landing planes in the wrong sequence, we don't want any bad things happening when we're dealing with air traffic control in flight. So the MLAT data and statistics. So in my panel, I can see the antenna. So in my pane, I could see the antenna signal and then all the ADS-B signals. So the ADS-B, the first one in the blue, are the connections that we're getting, the signals from the actual live antenna. The MLAT is the time of arrival, so departure and takeoff. And then the other is for more like military connections or anything that's like classified, things like that. Like I said, you can go, if you pull up the reports, you can go see like the specifics, the pain, and after my presentation, I will show all that. So the SDR Sharp. So SDR Sharp is a software where you can simulate different signals and different functions or different things you want to do, different experiments. So in this case, I was playing around with it, and I actually got live data from the BWI tower, which almost got me in trouble. I cut the signal. I knew how to cut the signal out, but it was decoding the ones and zeros through a software DSD Plus. And the thing with this stuff, you have to be careful because you can go to jail if you're not careful. Um, like with, and the thing is that like hackers and people like that have access to these tools. So the thing is now like with military FAA, they're trying to figure out different security measures to make sure that this data is not easily hackable. And they actually are separating the command window so they don't allow you to just come in and then analyze the data. So satellite data. This the radar system can actually look at satellites and their routes. So one big one big challenge I had was getting the satellite pictures back, like bringing them back to the Raspberry Pi. I got the code to be able to bring the files back, but I wasn't getting like clear pictures. And me and Dr. Ososanya were talking about different ways to attack it. Um, I think the biggest thing, the reason why clear, there weren't clear pictures was that the soft. I think we needed a bigger, like a better software to decode the information, and unfortunately, I wasn't able to do that because of money issues. But in the future, I'm definitely like looking to attack this issue better. But we were able to, on the Raspberry Pi, remotely be able to see wherever the satellites were going, if they were close to like UDC or in the vicinity, so we can have an idea of how to bring that data back using using the cloud. So and the amazing thing about this is just a Raspberry Pi. This is not like the big computer. And with the supercomputer, cascading those Raspberry Pis, you can be able to do cooler simulations. So the supercomputer. So unfortunately, the supercomputer, I wish I can have that to show you. It's at UDC, but this is a picture of the supercomputer. So the supercomputer can be set up in different ways. So you can have one master, one slave, one master. Any configuration you want, you can make. The purpose of me making this radar station, I want it to be interchangeable. So it's not just doing one specific thing; it could do multiple things at once. So in the command line, you can declare what's master, what's slave. Um, you can do simulations in different languages and Python, C++, but you have to decorate the library once you go in. So we have four Raspberry Pis here. You can cascade as many as you want, as long as the connection between masters and slaves is correct. At first, we didn't get a good connection, but after a while, I was able to simulations and actually be able to local flight aware data onto each Pi, which was good, which was great, which was good progress. In the future, when I um, when I go for higher studies, I definitely want to do supercomputer with hundreds and hundreds of these and do cooler simulations with the government. With my company Raytheon right now, they're looking to put me on a project with supercomputers similar to this, so I can be able to do cooler simulations. So this is where, so you can access this all remotely, the command line. So so if you see right here, this is Pi 1, Pi 2, Pi 3, Pi 4. My code right now is blacklisted. In my report, I go into more detail because the code is probably to put it all together in the architecture is probably hundreds and hundreds of lines. And I didn't want to bog you down with like, but I can access this all remotely on a dime. But the biggest, my biggest challenge is creating the back doors because in reality, I had to make sure that people couldn't hack my command line instantaneously. So there's security measures, and if you want to see that, you can come to me because that code is protected. Um, So the machine files, that's where all the IP addresses, all the security measures, and for each pod, there's separate machine machine files for security reasons. Also, if you go deeper, that's where I make my SSH connections and other relationships. But this is not easily accessible to the user. This is only accessible to me unless I give the users access to the command lines and machine files. This is very powerful because not only I can create as many as I want, but I can create those relationships through those machine files without coming in, jumping out, coming in and jumping out. And I don't have to physically be there. I can do that all through my remote server. Future work. So I want to make supercomputers I want to make systems similar to this for satellites. For my company, they're actually making that a reality. They're putting me on a project to create mini radar stations, um, tracking tracking satellites and different other things, so that it will give me more experience in the field. This senior project has really helped me because now the work I'm doing now I can bring into the field, and I have a different perspective on how to create system as an engineering major and as a professional. Here are my references.
Yeah. Okay.
And my acknowledgement is to C's, all the faculty of C's, Dr. Ososanya, Dr. Freddie Dixon, the STEM Center, and all the administrators. And I can do the demo and then I'll get to questions.
Yeah, go ahead with the demo.
Yeah, I am trying to. So here's one of my antennas. One of my antennas here. So the connection I was talking about. So this is where the RF cable would go. I'm not sure. I don't think people can see this clearly.
Clearly.
Can you see it?
Yes, we can.
Okay, so this is where the end mail would go into, and then from there so the end mail would go to the antenna. The SMA would go to the dongle. The dongle is this, the SDR Sharp dongle. So once all this is plugged in, then this is plugged into the Raspberry Pi. And then once all of this is connected, I can simultaneously that data. So this is one of my stations. So this is on at all times. So as long as I have power, then this will be working time all day, every day. And I can all the changes and all the architecture and things I can connect remotely. So this is one of my antennas. This is the 1088. This is the this antenna is used for the metal antenna is used for multi-purpose. So for satellite pictures and other things like that. If I had more money, one thing I would do is build my own antennas. But in terms of the budget, I didn't have any at the time. So like some of the parts I've gotten for free. Some of the parts I went out professionals and they give me parts and free stands and things like that. So I've done a lot to get parts and make this from a Raspberry Pi to a bigger system that could be used in the field. Also, what I wanted to show you. So this is for this radar station right here. This is the live feed. So if you put your cursor over, you can get the live flight data, and then also if you hit it, you can see more stats, where it's going, longitude, latitude, anything you want. You can find it. You can find it, and if it's not provided, then you can call FAA, and they would give you access to the data. So those are the big things I wanted to show you. This system, honestly, I could see in the future used in R&D and different things, and not just flight data, but in traffic data. Any scenario you want to analyze, it could be used. So that's one of the big impacts my project has. Is not just for flight data, and show meaningful data for different scenarios and different areas of study. So I will take any questions, concerns from all the faculty. Yeah, Dean Shoddy. You have your mic unmuted.
Can you hear me?
Yeah, I can hear you.
Yes.
Yeah, I can hear you. I can't hear you now.
It looks like he muted it again.
Yeah, you muted it again.
Okay.
Yeah, you're good. You're good. You're good. No, you muted it. You muted your mic again.
Dan Shetty?
You're good.
You can you hear me?
Yeah, I can hear you. I can hear you. I don't know why your mic keeps muting. Your mic keeps muting. I don't know why.
Just press it once, Dean Shetty.
You can?
We're good.
Yeah. Okay.
We're good.
Okay. Thank you. Whoever commented thanks for that. So while designing this project, like you might have had a chance to look at various standards, engineering standard, electrical standards. So what are the standard which you incorporated in the project?
So I had multiple standards, and I wrote it in my report. Different IEEE. Yeah, different
Right.
IEEE. I think one was like 521. It sets the standards for the transmission of different devices. So for low power and different systems. I think another one was like 821 is for like the transmission of packets over low power devices, such as Bluetooth and things like that. The
Right.
standards are very important in this because like there are certain things you cannot do, and you don't want to end up
Right.
like hacking someone's data or like going into someone's command window, where I almost did, where I was seeing like BWI's live data. So that's what you have to do.
Right. Okay. Like, please incorporate these in your report, your final
Yeah,
report.
I have it all in my report. It's all in my report. Yes. All
Okay. Right. Now, when you move from one area to another area, there are different FAA people take over. So does it matter, or what sort of interference it causes?
Interference in terms of. Could you ask it again?
In-
Sorry.
Right. So it doesn't cause any problems, is it? Like, because if you are, in this case, you came from Jacksonville to DCA.
Yeah.
So is it only one area, one region, or say if you are going to California from here, so will it cause some other problems? Because there are different people, different manage different areas, right?
Yeah.
Yeah.
So good question. So these devices can be placed these devices can be placed anywhere, any place. And also a nice thing about this is that you can mash your device. So it's not like it's like you weren't even there. So
Right.
there's a lot of other software behind the scenes that you can do that stuff without interfering with the actual transmission.
Mhm.
So that's one thing I put in the software. The thing is that like I said, me and Dr. O, we've done a lot of presentations. I've done presentations at ERN about this, and I've talked to professionals about this. And the thing is that like what you see, it's more to it because there's a lot of back end stuff that I did personally. It's just that I knew like in
Right.
20 minutes, it's very hard to go through every single aspect of it. But there is other things like that implemented in the
Thank
make
you.
sure that doesn't any interference.
So thank you.
There is a question on the chat for you. I'll
I
read it.
saw.
Okay,
I saw. I'm looking.
read the question out before you answer it.
The SDR Sharp work, the SDR Sharp work is old work and used programs from others that have been posted on the internet. You should note that. You should also explain what is the difference from what you did in the last 2 years. What is the purpose of discuss? Okay, let me do the first one. So the difference between the old work and the work before. So the work that we had at first was only analyzing like just basic signals and doing like basic work. Now we can do simulations remotely, and now it's one system. A lot of the systems you see out there are only doing like one specific thing. We can do the flight tracking. We can do the interfacing with MATLAB. We can do mass simulations. Like, unfortunately, like I said, like if I had the budget, I could have implemented a bigger system with the supercomputers, hundreds and hundreds of supercomputers. And honestly, like, and Raytheon has seen my work, and that's what I plan on doing in the field is creating systems for satellites, helping them put that on the ground. So that's the biggest difference is that before we were just doing basic, like just basic little simulations. Now we can attack real world problems in real time and get meaningful data and analyze that data. And what were what was the purpose of discussing the radar work when you were showing the SDR work? So the radar system and so the purpose of explaining the radar was that the before we weren't really focusing on like the radar aspect. We weren't focusing it on this project as a system. We were just focusing on the little functions. Before like the work I've done with you, this was just the stepping stones to get to this point where we can create systems that could be manufactured any like under for 100 and so this system could be honestly fabricated for like 100 $125, which is good because now like anybody can get their hands on this and do cooler simulation, do cooler work, and also do see what they can do with it. And my company, the company that recently hired me are looking for ways to see what other people can do with this. Professionals at their station could do with this and see other uses and other applications.
Any more questions for Leatham?
SDR Sharp.
Okay, how does the SDR Sharp fit in?
Sounds like somewhere in the very
Sounds like somewhere the Raspberry Pi is doing some DSP.
Oh yeah, so how I deal with that is I can send that. So the data for SDR Sharp, I can send that remotely to MATLAB to my server, and then from my server to MATLAB, and I can do more advanced work in Simulink and other languages. The decoding part, all that decoding is done through my cloud, my personal server, which is in my room. So everything goes to my server, and then once it goes to my server, I can send it to my desktop computer or my laptop. So like I said, it's any way you want to do it, we can do it. It's just a matter of like who's the company, who's the person, and how they want to implement it. I didn't set it like just one way. You can do this hundreds of ways.
Understand it. The outline. And
Any more questions for Keenan Leatham before we move on to the next group?
I think Hans was asking.
no.
Okay. We would like to thank you, the presenter.
I think someone had a.
Hello.
I thought someone had a question. I think Dr. Carol had another question.
Dr. Carol?
Yeah, it was in the chat.
She posted her questions on the chat.
Yeah. The reason why I show everything is because, like, unfortunately, like, I only have 20 minutes, and the thing is that there's more to this, and that's why the hands-on demo is the advantage of the hands-on demo, and I wish everyone was in person so that I could show you every single thing. If you want to know more and get into the nitty-gritty aspects, you can come to me. I can answer anything.
Thank you.
Thank you. Before we move on to the next group, I would like to acknowledge the presence of the Electrical Engineering Industry Advisory Board members. We have Dr. Ali Mahaja, Dr. Mike Marcus with us this afternoon. Yes? So we thank you for your presence with us this afternoon. Is there any other member of the Industry Advisory Board present here this afternoon? We have Dr. Caroline Carroll from the IEEE. Good afternoon. We're glad you could join us from the IEEE. We appreciate your presence here with us this afternoon.
Calling Space Ghost.
If there are no more questions for Keenan, we will move on to the next presentation on the electric motorbike conversion. Please remember to complete the evaluation form for Keenan later. Okay, next group.
Thank you for listening to my presentation. I appreciate it.
Congratulations on your job at Raytheon.